Hey, good morning. I'm going to go over the assignment from Monday, April the 19th. So for those of you that want a higher grade and you want to retake, you need to watch this video first and take notes. And then I will open up the assignment for you for an extra chance at it, an extra attempt, okay, for a higher grade. So I'm not going to give you the answers. I'll try not to. It's so hard. But I'm just going to go through how you would go about solving, okay? Which Venn diagram shows the correct relationship among different sets of numbers and the correct placement of negative 648? So remember what I said. Whole numbers are only the positive numbers on a number line, but include 0. Okay? So write that down. Whole numbers are only the positive numbers on a number line, including 0. Okay, so look at a number line, 0 on. On a number line, you don't see decimals and fractions on a regular basic kindergarten number line. You just see whole numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So make sure you write that down and you know that, okay? Integers now, I'm gonna erase this. Integers are on a number line, a regular basic kindergarten number line, are the positive and negative numbers on a number line. Oops. On a number line. So they're the positive and the negative numbers on a number line. Okay? So if you look at a kindergarten number line, it's 0 to the right to infinity, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, on and on and on. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, on and on and on. Okay? Infinity in both directions. You don't see a negative 1.5 on a kindergarten number line. You don't see a negative 5.25555. No. You only see whole numbers, both positive and negative. Whole numbers are positive, and the negative numbers are included with the integers, okay? Make sure you know that. So when you're doing this problem, make sure you pick the answer choice that is correct based on those definitions. Rational numbers are everything, okay? So it's positive numbers, negative numbers, decimals, fractions, all that. So once again, same thing. I just went over this. So make sure you pick the one that can only be an integer. That's the answer choice. Okay, pick the number, the answer choice that can only be an integer. It can't be a whole number is what I'm trying to say, okay? This one, so this one's pretty cool. Now pay attention. This is from 0 to 50 cents, okay? So from 0 to 50 cents, you need to figure out how much, if you were to divide this up into 10 like it is, how much is each line worth? Well, a kid in my first period said, Miss Simmons, we should find the middle first because you know 2 quarters, cut it in half is 1 quarter. And so the middle is going to be 25 cents, and that's going to be here. Now, if I count from 25 cents to 50, how much is each tab worth? I'm going to try 5s and see if that works. So 25 cents, let me try 30 cents, 35 cents, 40 cents, 45 cents, and 50 cents. Yes, that works. All right, awesome. Okay. So let's try, oh, I'm messing up. Okay, let's go from 0 to 25 cents then. We know we're counting by 5s, okay? So this is 5 cents, this is 10 cents, this is 15 cents, this is 20 cents, and 25, yes. So now, if you know your benchmark fraction, how much money is 1/3? Is 33 cents. It's so much easier for you to solve now. Where would 33 cents go on this number line? Okay? Dana placed the following points on a number line. So these are all fractions, and they look like improper fractions, meaning that the numerator is bigger than the denominator, okay? So what we need to do is convert all of these to money, convert them all to decimal or whole number if they go into it evenly. For example, negative 24/3. How many 3s are in 24? 8, and it's negative, okay? How many 2s are in 9? 4, and then 4 times 2 is 8. So 9 minus 8 is 1. So I have 1/2. So it's 4.5, which is negative. How many 2's are in 7? 3. How many is left? 1. So that's 3.5. How many 3's are in 15? 5. So that's how you convert them. Now, if you want to divide, that's totally fine. 9 halves, you would do 9 divided by 2 and just divide. 7 halves, 7 divided by 2 and just divide. 15 divided by 3, and then I forgot 24 divided by 3. So you can divide to get the number as well, okay? And you have to find, once you do that, you have to find which one is not correct. Point P, point Q, point R, point S. Which one is wrong? Okay. Now remember on the number line, let me show you something really cool. So if you're giving, say, negative 1.5. 1, 2, 3, 4, 5. What I would always do is I would find the positive version of it, which is the opposite for my number, which 1.5, $1.50, is between $1 and $2, okay? So it's gonna be right here, it's right in the middle. And then guess what? Did you know that the negative version of it is on the whole opposite side in the same spot though? So if it's negative 1.5, I know positive 1.5 is between 1 and 2. And guess what? I know it's gonna be between 1 and 2, but it's negative. And that's the easiest way to remember how to plot your negative points, because it can be a little confusing, okay? Next, you got to convert all of these to decimals. So 9.5 is 9.5, 9.38 is 9. You divide 3 divided by 8, unless you know your benchmark fractions. 9.12 is 9.12, 9.35 is 9.3 divided by 4. And then you put them in order from greatest to least. And that's how you'll find your answer. Okay, next, Marie used a thermometer to record temperatures of negative 3.4 degrees Celsius and 1.6 degrees Celsius. Which temperature in degrees Celsius is less than both? Okay, so remember on a number line, 1, 2, 3, 1, 2, 3, sorry. 1, negative 1, negative 2, negative 3, negative 4, negative 5. Okay, so 1.6, $1.60 is right between $1 and $2, and negative 3.4. So let me find positive 3.4. $3.40 is between 3 and 4. So I'm going to find it on the exact same side between 3 and 4. Bam. And I know that it's going to be negative 3.4. And remember, any numbers to the left are going to be smaller. Even though the negative number may be bigger, the actual number, the bigger the negative number, the smaller in value it is. I need you to remember that, okay? So any numbers that are going to be a bigger negative number is going to be smaller than negative 3.4. So that should help you out. Oh, back to this. Get rid of any positives because you know it's not going to be less than negative 3.4, right? So this is a strategy to use. You can automatically get rid of 2 of your answer choices, right? Okay. Okay, the table shows the portion of a day 4 students use to build a website. Which list shows the students in order from greatest amount to least amount? Now, something I hadn't thought about. I'm telling y'all, y'all are smarter than me. I was doing it where I converted all these to decimals, and then a kid in my first period was like, Ms. Simmons, it would be so much easier to convert these all to percents because you already have 2%. I was like, yes, you're so right. And so what I was going to tell you is whatever strategy works best for you, you do you, boo. So if you want to convert these all to decimals or percents, that's fine. Whatever works for you, okay? So let's do percents first since I'm so intrigued with that idea. So 7/25. Now remember, we have the scaling. So 25 times 4 gets 100. 7 times 4, you have to multiply the numerator by the same scale factor, is 28. Any number over 100 is the percent, and that's 28%. Okay? 3/10. is super easy. 3/10, convert it to a percent, move the decimal over 2 places to the right, and that's 30%. So if you want to do it that way, it's so much easier to compare the percents now, okay? Now I'm going to show you the other way if you wanted to convert these all to decimals. So if you have 29.4%, remember you divide by 100, which is the same thing as moving the decimal 2 places to the left. So you get 29 cents. 37.6, you get 37 cents. 7/25, I would scale it, the denominator, to 100, and I would get 28 hundredths, and the way I would write that is 28 cents. And 3/10, I would write it how it sounds, 3/10, which is 30 cents. And now you can compare the cents to get your answer, okay? Please get this. I really need y'all to understand this. All right, which list shows the numbers in order from least to greatest? Same thing, guys. Convert all of these numbers to money. And once you've converted it to money, the important thing for this value, this particular question is the bigger the negative number, the smaller value is the number. Okay, that's going to be key to this particular question, okay? And then remember, you have to put the questions in order from least to greatest. So from the smallest to the biggest. So your biggest negative number is going to go first, okay? And I didn't circle F because that's the answer. I circled it because I want you to know you need to convert all of those different fractions or numbers, making sure they're all decimals to solve. And that's it. All right, good luck on the retake.